Hey everyone, and welcome back to The Explainer. Today we're diving into something that absolutely has the potential to fundamentally shift how you manage your large language model infrastructure. We're going to be deconstructing a massive, highly effective cost-saving technique for LLM optimization that was built by the team over at Headroom. Now, if you're building AI applications right now, you already know that managing context and token costs, well, it's a constant battle, right? But what if the way you're currently sending your prompts is actually accidentally sabotaging your own efficiency?
I want you to really think about this for a second. Why are you letting your API budget drain away on redundant computations? Every single time you send a massive system prompt, you're more than likely asking the AI to process the exact same foundational instructions it literally just processed a second ago for a completely different user. Think about it like this. You wouldn't pay a contractor to completely rebuild the foundation of a house every single time you just wanted to change the paint color, right? So why are we doing exactly this with our LLM providers?
Okay, let's dive into this. Here is our roadmap for the explainer today. 1. We'll diagnose the broken cache problem. 2. We'll explore the CacheAligner solution. 3. We'll look at provider-specific rules. And 4. We'll calculate those compounding savings.
To kick things off, I want to anchor our entire discussion around one staggering number, 96.2%. That is the potential cost reduction we're talking about today. Now I know, it kind of sounds like a mathematical mystery right now, maybe even a bit too good to be true, but I promise you, by the end of our time together, we're going to completely demystify this. We are going to reconstruct exactly how Headroom achieves this massive number, step by step.
All right, let's jump right into Section 1, the broken cache problem, or as I like to call it, the invisible enemy in your prompts.
So there's this invisible enemy hiding in your prompts right now, and it's actively destroying your optimization efforts. And the crazy part is, it's often disguised as best practice. To really understand how it's breaking your system, we need to talk about the KV cache. Think of the KV cache like ordering the usual at your favorite local coffee shop. When you walk in, the barista already knows your super complex order. The heavy lifting of figuring out what you want, it's already done. They don't have to relearn your preferences just because you happen to be wearing a different colored shirt today. For LLMs, providers cache prompt prefixes so they can just reuse previously computed attention states. If the input is identical to something they've seen recently, they just skip that heavy reprocessing phase. It saves them computing power, and crucially, it saves you money. But, you guessed it, there's a catch.
Enter the prefix breakers. We're talking about things like today's date, unique user session IDs, or timestamps. System prompts are usually absolutely full of this kind of dynamic content. And here is the brutal reality. Even a single character difference at the very start of a prompt completely invalidates the entire provider cache. So if you drop a timestamp right at the top of your 10,000 token system prompt, the LLM provider sees that as a brand new, never-before-seen 10,000 token prompt every single time. That tiny, dynamic little detail forces the provider to recompute everything from scratch. Going back to our analogy, it's like your coffee shop barista suddenly getting amnesia just because you changed your shirt.
So the crucial point is, how do we fix this? That brings us to Section 2, the CacheAligner solution, engineering a stable prefix.
We basically need a way to keep those foundational instructions identical while still passing along that necessary dynamic information. If you look at the comparison here, a typical unoptimized setup has the dynamic date sitting right at the top, followed by the massive system prompt and then the user query. Naturally, the cache breaks immediately right there at the date. But with a CacheAligner prompt, notice the structural shift. It extracts that dynamic content and pushes it all the way down to the very end of the message. That means the massive system prompt is now firmly locked at the front. By just reorganizing the sequence, the bulk of your prompt remains entirely stable across multiple requests. It's a simple shift, but a total game changer.
The technical term for what this guarantees is byte-identical prefixes, and honestly, this is non-negotiable for modern LLM infrastructure. The start of the message literally must be exactly the same, down to the byte. By ensuring the front-loaded content never shifts, CacheAligner guarantees that the provider's KV cache actually hits successfully, which is exactly what unlocks those massive discounts we were talking about earlier.
Okay, moving to Section 3. What's really interesting about this next part is navigating the different LLM rules, because every provider handles this a bit differently.
Since the major AI giants definitely don't share some universal caching standard, Headroom automatically applies the optimal strategy for whichever provider you're routing to at the time. Let's break down the big three, starting with Anthropic. Now, they are incredibly generous. They offer a massive 90% discount on cached input tokens, but you got to play by their rules.
They require explicit cache control blocks in the API call to actually mark the content as cacheable. Plus, there's a 25% premium cost the very first time you write to that cache and a short 5-minute time to live window, though that does extend every time it gets a hit. Headroom actually steps in and automatically inserts these explicit cache control breakpoints at the perfect spots in your messages, so those stable prefixes get cached securely and you don't have to write a single extra line of code.
Next up, we have OpenAI, and their approach is completely different. They give you a 50% discount off the input price, but the activation is entirely automatic. No explicit API markers needed at all. Basically, if consecutive requests share the exact same prefix, they just reuse the cache states. But, and this is a major caveat, your shared prefix must be at least 1024 tokens long, and it must be strictly byte identical. Because CacheAligner secures that stable prefix, by perfectly shifting the dynamic content to the back, it effortlessly satisfies OpenAI's strict automatic prefix matching requirements.
And finally, we have Google. They're offering a solid 75% discount. But get this, their minimum cache size is a colossal 32,768 tokens. They use an explicit cached content API, which allows you to explicitly cache huge documents, system instructions, or massive toolsets. Here, Headroom acts as your sort of automated manager. It handles the entire cached content lifecycle, seamlessly creating and refreshing these huge cache objects in the background, so you never have to worry about managing those states yourself.
Let's move to Section 4 and see how this builds into something truly spectacular. We're going to reconstruct that 96.2% savings.
So the way Headroom's features are designed, they actually stack together like a combo move. Step 1. A feature called Smart Crusher compresses your original prompt, dramatically shrinking the token count. Let's say it takes a 100,000 token prompt down to just 20,000. Step 2. CacheAligner steps in. It stabilizes the prefix of that new 20,000 token prompt. Because of that stability, 18,000 of those tokens perfectly hit the provider's cache. And step 3, we apply the provider's discount. In this specific scenario, let's say we're using Anthropic's 90% cache reads discount.
When you look at the math, it violently shrinks your costs. To put that into perspective, you started with 100,000 original tokens. Because of the initial compression, you're only actually sending 20,000. Out of those 20,000, let's say 2,000 are dynamic tokens, so those get charged at full price. But the remaining 18,000 tokens, they hit the cache, meaning they get that 90% discount. So you're only paying the equivalent of 1,800 tokens for them. Add those 2,000 full-price tokens together with the 1,800 discounted tokens, and your final effective cost is just 3,800 tokens. You just delivered 100,000 tokens worth of value to the LLM, but you only paid for 3,800.
And boom, there's our punchline. Total savings, 96.2% compared to the original 100K tokens. You see, that magic number we talked about at the very beginning of the explainer? It wasn't magic at all. It's literally just brilliant compounding math. By combining intelligent compression with structurally engineered stable prefixes, you're absolutely unlocking a completely different pricing tier for your application. So I want to leave you with a question to really chew on today. Go take a look at your code. Is a single dynamic timestamp, or maybe a date or a user ID, just sitting up there at the top of your master system prompt? Is that one invisible line of code secretly draining your entire API budget right now by breaking the cache on every single call? The good news is the tools absolutely exist to fix it, and as we've seen today, the savings you get aren't just incremental, they are completely transformational. Thanks so much for joining me on this explainer. Keep learning, keep optimizing, and I'll see you next time.